Hello and welcome dear Mathletes once again to Mathlete Minds. We continue our journey of applications of trigonometry, and in this particular video we'll be taking up some higher order thinking skills questions pertaining to it and related to CBSE Class 10 mathematics. In the previous videos we have done the technicalities and the technical terms that we need to understand very thoroughly. Now let's move on with some more questions pertaining to it. So the first one over here is, of course, the angles of depression of two ships from the top of a lighthouse are found to be 45 degree and 30 degree. If the height of the lighthouse is 200 meter and the ships are on either side of the lighthouse, then find the distance between the ships. So here you can see this is a picture of this lighthouse, and there are two ships on either side of it. Obviously the closer one will make a greater angle and the further away will make a lesser angle. This is the representative geometrical figure which is mandatory to be drawn, and this is the, since angles of depression are mentioned over here, this horizontal over here at the top of the lighthouse, AC is the lighthouse, so A is the top of the lighthouse from where the observation is being made, or the observer is positioned at the point A. So this observer over here sees that the angle of depression of one of the ships at position B is 45 degree and the angle of depression of the second ship is 30 degree. So when we do this construction, this perpendicular lighthouse has to be drawn as a perpendicular over here. BD is joined, that is the distance between the two ships is considered to be the horizontal over here, and this is the other horizontal here at the top of the lighthouse. So this angle being 45 degree, the interior alternate angle, this angle becomes 45 degree. Similarly, this angle being 30 degree, this interior alternate angle becomes 30 degree. And AC is given as 200 meters. So what we need to do is this figure now, once you draw these angles in perpendicular over here, you see that you get two right angle triangles. One is ACB and one is ACD. Now let's take each right angle triangle separately and analyze and see what are the values we are getting. Here we have taken BC as X and CD as Y meters. So if I take the first triangle ACB, from there I get tan 45 degree is equal to AC upon BC. AC upon BC, that is 200 by X. That means X is equal to 200 meters. Tan 45 is 1, so X is equal to 200 meters. In the second triangle we get tan 30 degree is equal to AC upon CD, that is 200 by Y. Now tan 30 is 1 by root 3, so this becomes 200 by Y, or Y becomes equal to 200 root 3. X is 200, so now the distance between the ship, that is X plus Y, that will be equal to 200 plus 200 root 3. So in order to simplify, let us take out 200 common, 1 plus root 3, that is 200 into 2.732, taking the value of root 3 as 1.732. So this becomes equal to 273.2 multiplied by 2, that is 4, 6, 14 and 5. So 546.4 meters is the distance between the two ships. I hope this is clear. Now basically in these questions the geometrical figure has to be understood and drawn, and once you draw the figure correctly, automatically the solutions come. Now the next question is the angle of elevation of a stationary cloud from a point 2500 meters above a lake is 30 degree and the angle of depression of its reflection in the lake is 60 degree. What is the height of the cloud above the lake? So here you can see this is a visualization of the same question over here, and this is the person at this top of a pillar over here, and the height of this pillar is 2500 meters. He is looking at the top of the cloud and the angle of elevation is given as 30 degree. But when he looks down at the same point inside the water level, he finds that the angle of this depression of the reflection of the same point on the cloud. Say if he is looking at the top of the cloud, he takes a point at the bottom, the reflection of the same point at the bottom, and he finds that the angle of reflection is, angle of depression of the reflection is 60 degree. So now we need to find the height of the cloud above the lake. That is, we need to find above the lake what is the height of the cloud. So this is the geometrical figure. This has to be drawn this way. This is the water level represented by BQ over here. The person is standing, this is the observer over here, and he is standing at a height of 2,500 meters above the water level. The cloud is at this point over here. He looks at the cloud over here and he finds that the angle of elevation is 30 degree. And then the same point, he looks at the reflection of that and he finds that the angle of reflection is, angle of depression of the reflection is 60 degree. So now, what we need to understand, the important point over here in this particular question is, the water level or the water is taken as a plane mirror over here, and the first law of angle of reflection is followed here. That is, the object distance will be equal to the image distance. So if this is the mirror over here, BC and BR will be of the same distance. So now we know if OQ is 2,500 meters, and this we have drawn as a horizontal over here. QB is also horizontal, the water level. So automatically AOQB becomes a rectangle. So AB becomes 2,500 meters. Let us assume AC to be H. So BR will be equal to H plus 2,500. Now, if you want, you can complete this figure this way. You can draw the interior alternate angle over here and take this also as a right angle triangle, but I'll take the straight figure over here and take these two triangles, right angle triangles. One is AOC, one is AOR. So now, in triangle AOC, we get over here tan 30 degree will be equal to AC upon AO. That is equal to H upon X. I have assumed AO to be X meters. So 1 by root 3 is equal to H upon X. So here we get X is equal to H root 3 meters. So this is your first equation. Now we take this triangle AOR. From the triangle AOR, tan 60 degree is equal to AR upon AO. AR upon AO. This is the perpendicular and this is the base. So AR upon AO. Now if you look carefully, BR is H plus 2,500, AB is 2,500. So AR becomes equal to H plus 5,000. AO is again X over here. So tan 60 degree is equal to H plus 5,000 by X. So that means root 3x is equal to H plus 5,000. This is your second equation. Now going back to the first equation, from the first equation we get X is H root 3. So if we do the substitution over here, we get here root 3 into root 3 H is equal to H plus 5,000. So this becomes 3H is H plus 5,000, or 2H is equal to 5,000. So H is equal to 2,500 meters. So this is the solution. That means this height AC, or the height of this from this point from the observer, right above the water level. This is 2,000. Sorry, he is standing at a height of 2,500 meters. So the height of the cloud above the water level from here till here, that is BC. So BC will be equal to 5,000 meters. We have to find out the height of the cloud above the lake. That means from here we need to find out the height of the cloud. We have found out only H, but we need to find this distance, that is BC. So this BC is 5,000 meters. I hope it is clear. The drawing of the figure in this particular question is immensely, it has to be understood thoroughly, it has to be drawn correctly, and then only you can proceed with the solution. The next question is, at the foot of a mountain, the elevation of its summit is 45 degree. After ascending 1000 meter towards the mountain upper slope of 30 degree, the elevation is found to be 60 degree. Find the height of the mountain. So you can see this is a mountaineer. He is climbing the mountain, and when he looks from the bottom, from below the mountain, he finds that the elevation is of the summit, that is peak of the mountain, is 45 degree. Then he climbs a distance of 1000 meter at an angle that is 30 degree up the mountain, and from there he looks again at the summit and he finds that the angle of elevation is 60 degree. So the question says, find the height of the mountain. So this is the picture to be visualized, and now here we have the geometrical representation. Initially the observer is over here, the mountaineer is at this point A. E is the top of the summit of the mountain. We need to draw this EC as the perpendicular to the base over here. AC is the horizontal, and from here if you look at the mountain peak, this complete angle, that is angle EAC, is 45 degree. Now mountaineer climbs up the slope AF at an inclination of 30 degree, and the distance that he climbs up is 1000 meters. Now from here at this point F, when he looks at the top of the mountain, the angle of elevation is 60 degree. Now I have assumed we have completed the figure this way. You draw the perpendicular from the point where he stops to the base over here. So this is FB, and from the point F again a perpendicular is drawn over here to this line, which is representing the vertical mountain over here, and this is 90 degree over here. So now you see the figure has got two right angle triangles and one a rectangle over here. So first of all, we need to consider the triangle EAC, the outer triangle, and this is also a right angle triangle over here. So from the right angle triangle EAC, we get tan 45 degree. Tan 45 degree is equal to EC upon AC. That is equal to, I have taken EC as H, so EC upon AC. That means H is equal to AC. The height is equal to AC. Now we take this triangle over here, that is ABF. Now in this triangle ABF, this angle is 30 degree. And the vertical distance FB is Y meters. AB is not known. So now you need to pay attention for this particular triangle. This distance AF is given as 1000 meters. So what we are going to do is, now instead of taking sine 30, we will take here, instead of taking tan 30, we will take over here sine 30. So sine 30 will be equal to FB upon AF. Now FB is represented as Y and AF is 1000. Sine 30 is half. So half is equal to Y by 1000, which implies Y is equal to 500 meters. That means this vertical distance is 500 meters. Now let us find this distance AB also, applying cos 30 degree. Cos 30 degree is equal to AB upon 1000. Now cos 30 we know is root 3 by 2. So root 3 is equal to AB by 1000, which implies AB is equal to 500 root 3. So this distance becomes equal to 500 root 3, and this vertical distance is 500. Now we need this AB because we have to calculate BC from this total distance AC. So now BC can be written as H minus 500 root 3. Now we take up, now if you look at this figure over here, FDCB, this becomes a rectangle. This is X, this is Y, these are 90 degrees, so automatically this becomes a rectangle. Now let us take this triangle over here, triangle EDF. From here we get tan 60 degree. Tan 60 degree is equal to ED upon FD. ED upon FD. So ED is equal to this total height h minus dc, that is ed minus dc, alright, divided by fd. Now fd is equal to bc, and bc can be written as ac minus ab. So tan 60, that is root 3, ed is h minus y, by ac, that is equal to h again. Here we got h is equal to ac, h minus 500 root 3. Now y is equal to 500. So in the numerator we get h minus 500, and in the denominator h minus 500 root 3. Now let's cross multiply. So we get here root 3h minus 500 into 3 is equal to h minus 500. So again we get here root 3h common, root 3 minus 1, transfer h to the left hand side. This becomes 1500 minus 500, that is 1000. So h is equal to 1000 by root 3 minus 1. If you rationalize it, you will get here root 3 plus 1 into root 3 plus 1. That makes it 500 into 2.732. This will become root 3 minus 1 into root 3 plus 1 will become 3 minus 1, that is 2, using a squared minus b squared formula. So now if you multiply this, you get here 273.2 into 5, that is equal to 5 2s 10, 5 3s 15, carry over 1, 36 carry over 1, and 7 5 35 plus 1 36, carry over 3, 5 2s 10 plus 3, that is 1366 meters. So what is this 1366 meters? This is h, the height of the mountain, 1366 meters. I hope this is clear. Here we have to take up 4 different right angle triangles and proceed step by step. So ultimately you will get easy. Connect the values with each other. It's not necessary that you take it in this particular order itself. You can take this big triangle, then this triangle, and proceed that way also. So, but make different equations, frame different equations. This is the first equation that we get here. Then we get second equation, y is 500. Then we get this AB, that is 500 root 3. And then we get BC as equal to h minus 500 root 3, that is fourth one. Then we get your tan 60 value, that is the fifth one. And ultimately you get the value of h. So this is how you need to solve this particular question. The next question is, a man in a cliff observes a boat at an angle of depression of 30 degrees, which is approaching the shore to a point immediately beneath the observer with a uniform speed. 6 minutes later, the angle of depression of the ship is found to be 60 degrees. Find the time taken by the ship to reach the shore. So here, the person is standing on the top of the cliff and he observes 2 positions of a ship. Initially, the ship is further away, then it comes closer to the cliff, to the bottom of the cliff. Now, important thing in this question is uniform speed. That means the ship has not changed the speed at all throughout its journey. So, man on the top observes that the angle of depression initially of the ship, when it is further away, is 30 degrees, and when it comes closer, it becomes 60 degrees. But the time to change this angle from 30 to 60 has been mentioned as 6 minutes. So now, if we draw the geometrical figure over here, this is the horizontal, the observer is at this position. This is the height of the cliff, AO, and this is represented by H. And initially, when he looks down at the first ship, at the ship over here, the angle of depression is 30 degrees. As the ship comes after 6 minutes to this point B, the angle of depression becomes 60 degrees. So we need to find the time taken by the ship to reach the shore. That means ultimately when he reaches this position A or below the cliff, what is the time taken for that? So now let's try to understand this question more thoroughly. Now when he is at this, when the ship is at this point C, the distance, coming back to this uniform speed, we know distance is equal to speed into time. So here in both the cases the speed is uniform. So let us represent the speed by s. Distance is d and time is t. Time is given as 6 minutes for this journey, that is BC. Now, if we take the first equation over here, we'll get here tan 30 degree. Of course, you can understand if this angle is 30 degree, this angle will also be 30 degree interior alternate angles. So tan 30 degree will be equal to AO upon AC. That is equal to H upon X plus Y. Tan 30 is 1 by root 3 is equal to H upon X plus Y. So X plus Y is equal to H root 3. Then we take this triangle AOB. From here we get tan 60 degree is equal to H upon X. So tan 60 is root 3, so we get H is equal to X root 3. So now H becomes equal to X root 3. So if we take the first equation and substitute the value of H over here, that is X plus Y is equal to H root 3, and here if I substitute the value of H as X root 3, I'll get X plus Y is equal to X root 3 into root 3. So X plus Y will become 3X. That means Y is equal to 2X. So this means we have taken the distances as X and Y. So this means this distance BC is twice the distance AB. So obviously if the time taken by the particular ship to complete this distance Y is 6 minutes, and since it is moving at a uniform speed, the speed is the same. So logically also if you analyze it, this distance X will be, he will take only 3 minutes to cover the distance AB, half the time. This is twice the distance, so this time will be half. You can relate from here also, the distance is twice over here, so automatically the time taken will be half the time over here. X is half the distance. So the time taken will be half the time, that is 3 minutes, since the speed is constant. Now, the question says that find the time taken to reach the shore. That means he has taken 6 minutes here, 3 minutes here. So the time taken to reach the shore will be 6 plus 3, that is 9 minutes. So sometimes you are asked this question, that is how much time does he reach to come from this point to this point, and sometimes the total time taken to reach the point the point A, the bottom of the cliff for the shore. So both the questions are asked here, find the time taken by the ship to reach the shore. That means from this position to this position, what is the time taken? And if the term is over here, find the time taken by the ship to reach the shore from this position after which the angle changes. Something like that is mentioned. In that case, it will only be 3 minutes. So you need to understand the words of the question carefully. The next question is, a ladder rests against a wall at an angle alpha to the horizontal. Its foot is pulled away from the foot of the ground through a distance A, so that it slides a distance B down the wall, making an angle angle beta with the horizontal. Show that A by B is equal to cos alpha minus cos beta by sin beta minus sin alpha. So here we have a ladder. Initially it was at this height. The ladder is the same. The length of the ladder will not change. So that you must keep in mind. Now it is sliding down the ground. It is pulled away and through a distance A. So the distance through which it is pulled away is a distance A. It comes down through a distance A, and it slides a distance B down the wall. Slides a distance B down the wall, and on the ground a distance A. So here, it's again the question says, show that A by B is equal to cos alpha minus cos beta by sin beta minus sin alpha. So the geometrical figure will be drawn here this way. You must remember here AD is representing the ladder, so AD will be equal to BE. The ladder's length is not going to change. So when the ladder is pulled away from the wall. Alright, it says that it is pulled away through a distance A from on the ground, and it slides a distance B down the wall. So this distance AB is small b and this distance is small a. Now we get over here, if you complete the figure, you get here two right angle triangles. One is ACD, one is BCD. Now if you look at the question here, the question pertains to cos alpha, cos beta, sin alpha. So what are we going to do? We are not going to calculate tan alpha or tan beta. We are going to talk about sin alpha, sin beta, cos beta. Now sin alpha, for that we have to consider the triangle ACD. For sin alpha, we will get over here, sin alpha will be perpendicular by hypotenuse, that is AC upon AD. That is, AD is the length of the ladder, let us take it as L, small l. So AC, that is equal to B plus Y by L. So sin alpha is this. Then sin beta. Sin beta will be equal to BC upon CE. So this is equal to Y upon X plus A. Then we have cos alpha. Cos alpha we will take from the triangle ACD, that is equal to CD upon AD. So CD again is X and AD is equal to L. Sin beta is sin beta will be BC upon BE. So this will be BE, that is Y upon L. Alright, and cos alpha is X upon L. Cos beta is equal to CE upon BE. CE upon BE. This is BE, not, this will be B. So CE will be X plus A by L. Now getting back to this relation, the right hand side relation cos alpha. Now cos alpha is represented as X by L. Cos beta is minus X plus A by L divided by sin beta is coming as Y by L and sin alpha is B plus Y by L. So if you simplify this further, you will find here, you get here X minus A by Y minus B minus Y. The LCM will be L by L, that is eliminated. So with this gets eliminated. Minus A by minus B is A upon B, which is the left hand side. Here it would be BE by, like I just took it as a tan beta over here. So we have to take here sin beta. The next question is, a boy standing on the ground and flying a kite with 100 meters of string at an angle of elevation of 30 degrees. At the same time, another boy is standing on the roof of a 10-meter high building and flying his kite at an angle of 45 degrees. Both the boys are on opposite sides of the kites. Find the length of the string that the second boy must have so that the two kites meet. So the first boy is standing on the ground, the second boy is on the particular building over here, and the question says that the length of the first boy's kite string is 100 meters. So take this as the first boy at this position, see in the geometrical figure here, and the second boy at this point over here, that is F, at a height of 10 meters. The height of the building is 10 meters. Second person is standing over here and flying his kite. This length we have to find out. So now we get over here this type of figure. When you draw the geometrical figure, the first boy is here. He flies his kite. The kite is over here. And when you draw perpendicular EB, you get one right angle triangle over here. Then again, this second boy at a height of 10 meters, he is flying a kite from here. So from again we get another right angle triangle. And these 2 points will meet because the question says over here, Both the boys are on opposites. Find the length of the string so that the second boy must have, so that the two kites meet. So at this position the kites must meet. So that is why we get this type of figure over here. Now if we take the first triangle ECB, right angle triangle, from there we get tan 30 degree. Tan 30 degree is equal to EB, we'll take over here instead of, because this is given as 100 meter, we will not take tan 30, there is no need of the base calculation over here. So we'll take here sine 30 degree. Sine 30 degree is equal to EB upon EC, that is equal to EB by 100. So EB comes as, sine 30 is half, so EB comes as 50 meters. This height comes as 50 meters total. Now this is 10. So from the total 50, so we'll get over here ED, that is equal to EB minus DB. And DB is 10, this becomes a rectangle over here, because if we draw the horizontal, this is 90, this is 90, so this is a rectangle over here. So 50 minus 10, that is equal to 40 meters. Now we take this triangle EFT. In this triangle EFT, we have to find this length EF. So again we take over here sine 45 degree. So sine 45 degree is equal to ED upon EF. So this is 1 by root 2 is equal to ED is 40, EF is L. So length of the string will be 40 root 2 meters. We can put the value of root 2 as 1.414 and calculate that. Supposing we take it as 1.414, over here it become 14.14 into 4, that is equal to 56.56 meters. 56.56 meters. For 16 1, this becomes 56, 14 4s 56 and 14 4s 56. So that is the length of the kite the second person must have, so that the two kites meet at the point E. So these were some variety of questions that we have discussed over here. Hope you like the content. Kindly make your comments. If there are other questions to be solved, we can discuss that. Thank you for watching. Kindly like, share and subscribe to the channel.